This is the progress video for the FSAE rear suspension rocker topology optimization for MEMS 5001. I'll start off with the assembly the rocker is part of. This optimization focuses on the rear right rocker, which has 4 bolted connections. The first connection is the frame tab, which bolts onto a bearing that is pressed into the rocker. The second is the push rod, which rotates the rockers when there's a loading from the ground. The ARB, the anti-roll bar, that acts as a torsional spring connecting the rear right rocker to the rear left rocker at point 3, and ultimately the spring and damper combination bolting on at location 4. Before I discuss loadings, I'll go over the mesh that was created. The rocker is milled out of 7075 aluminum. The generic block attaching all 4 points is created and meshed to 3,600 cells. The average cell size is set to 0.2 inches, and the minimum element size is set to 0.01 inches to refine the areas around the bolt holes. RBE2, rigid body element 2 nodes, are created in the centers of each hole to be able to transfer point load into a distributed load along the face of the bolted connections. Each of these points is constrained to 6 degrees of freedom. The center point is infinitely stiff. The loading constraints discussed in this slide are according to what the car sees in a left roll. The damper and spring loading is split between the 2 holes and is a total of 800 pounds. This is the spring rate times the maximum deflection of the spring. The damper itself is angled at 8 degrees in a static condition, so the 800-pound force is broken into components. The ARB will roughly see half the load the damper will, so therefore a 400-pound force vertical load going downwards is added since the ARB pushes the rocker downwards in a left roll. The push rod has no force added. It is fixed in the vertical direction. The frame mount has 1 degree of freedom, translation around the z-axis to mimic the axis of rotation. FEA simulation is run to ensure the defined case above is satisfactory. Since the FEA is able to run and has output reasonable results, it is safe to say the rocker setup is ready for topology optimization. From here, optimization objectives, responses, as well as constraints will be created to decrease the amount of volume and ensure that the displacement of the rocker is not significant.